take inverse trigonometric function. We know that if a function is 1, 1 and on 2, then it is invertible. Then you can find the inverse of that function. Let S is 1, 2, 3, whether f s to s, here s is the domain and another s is the codomain, defined as f 1, 1, 2, 2, 3, 3. As in this function, as distinct elements have distinct images, and each element of codomain have pre-images in domain. Therefore, f is 1, 1 and on 2. Each and every element has single image. So the x1 value, y1 value. So that 1, 1, 2, 2, 3, 3 is 1, 1 on 2. So that it is invertible. Domain and range. Domain and range of trigonometric functions. Function, domain and range. Function is sin x. Domain is real. Range is -1, 1. Cos x. Domain is real. Range is -1, 1. Then tan x. R minus x such that x is equal to 2n plus 1 into pi by 2, where n is the element of integers and range is real. Cot x. R minus x such that x is equal to n pi, where n is the element of z and range is real. After that, sec x. R minus x such that x equal to 2n plus 1 into pi by 2. N is the element of integers and the range is r minus -1, 1. Cosec x. R minus x such that x is equal to n pi. N is the element of integers and range is r minus -1, 1. So first of all, trigonometric function. Their domain and range. Function sin x, and sine function domain is real. Range is -1, 1. Cos domain is real. Range is -1, 1. Tan x, all real number except x is equal to 2n plus 1 into pi by 2, where n is the element of integers and range is real. Cot x, similarly cot x is equal to all real number except x is equal to n pi, n is the element of integers and range is real. Sec x, r minus all real number except x is equal to 2n plus 1 into pi by 2, n is the element of integers, r minus -1, 1 is the range of that function. Cosec x similarly, r minus x is equal to n pi, n is the element integer, r minus -1, 1 is the range of this function. So that this is a trigonometric function. In trigonometric function, domain and then range, and in inverse trigonometric function, range converted to domain and domain converted to range. Yani inverse. That is, inverse of this function is range is your domain and domain is your range. Similarly, inverse trigonometric function, range and domain of the inverse trigonometric function. Range and codomain of the inverse trigonometric function. Inverse trigonometric function. Domain and range of inverse trigonometric functions. The range of trigonometric functions becomes the domain and the range of trigonometric functions becomes the domain of inverse trigonometric functions. Here are some conditions. Functions domain, range, and principal value branch. Value branch. First of sine inverse. Let y is equal to sine inverse x. Domain is minus 1 comma 1 and range is minus 3 pi by 2 comma minus pi by 2 minus pi by 2 comma pi by 2 pi by 2 comma 3 pi by 2, etc. But principal value of this inverse function is minus pi by 2 to pi by 2. This is the principal value of inverse trigonometric function sine inverse x. Principal value is minus pi by 2 to pi by 2. Similarly, cos inverse x. Domain is same, minus 1 comma 1 and range is minus pi comma 0, 0 comma pi and pi comma 2 pi, etc. But principal of value is 0 to pi. Similarly, y is equal to tan inverse x. You can find tan inverse x. Domain is real. Range is minus 3 pi by 2 comma minus pi by 2 minus pi by 2 comma pi by 2 and pi by 2 comma 3 pi by 2. But the principal branch of this is minus pi by 2 to pi by 2. Then y is equal to cot inverse x. Cot inverse x, again domain is real, range is minus pi comma 0, 0 comma pi, minus pi comma 0, open bracket, 0 comma pi and pi comma 2 pi. But principal value of this is 0 comma pi. Then y is equal to sec inverse x. Domain is all real number except minus 1 comma 1. Minus 1 comma 1. Except minus 1 comma 1. Then range is minus pi comma 0. Minus pi by 2, 0 comma pi, minus pi by 2. Last one is pi comma 2 pi minus 3 pi by 2 except this, minus 3 pi by 2. But the principal value of this is 0 comma pi except 0 comma pi except pi by 2. Last one is cosec inverse x. Cosec inverse x. The cosec inverse x function is cosec inverse x. Domain of this is all real number except minus 1 comma 1 and range is minus 3 pi by 2 comma minus pi by 2 minus pi, except this. Second one is minus pi by 2 comma pi by 2 except 0. Cosec 0 is not defined. Next one is pi by 2 comma 3 pi by 2 minus pi, but its principal value is minus pi by 2 comma pi by 2 except 0. So this is the domain and range of the inverse trigonometric function. Y is equal to sin inverse x. Domain is minus 1 comma 1. Range is minus 3 pi by 2 to pi by 2 comma minus pi by 2. Next one is minus pi by 2 to pi by 2. Next one is pi by 2 comma 3 pi by 2. And principal value of this branch is minus pi by 2 to pi by 2. In examination, first of all, one question is write the principal value of inverse sin inverse x. So that is minus pi by 2 to pi by 2. If they can say that you find the other than the principal branch, then you can write minus 3 pi by 2 comma pi minus pi by 2 pi by 2 comma 3 pi by 2. This is the other than the principal branch is two values. These two values are the other than the principal branch, but this is the principal branch. Similarly, cos inverse x minus 1 comma 1 minus pi comma 0 0 comma pi comma 2 pi. These are the range of this cos inverse function. But principal branch of this function is 0 comma pi. Other than principal branch, you can write minus pi comma 0 and pi comma 2 pi. Similarly, tan inverse x, cot inverse x, sec inverse x, and cosec inverse x. So this is the domain and range, and the principal value of this branch is this. Whenever no branch of an inverse trigonometric function mentioned, we consider the principal value branch. Always when solving the question, you always use principal values branch. Principal value branch, this function is always 1 1 on 2. Domain, each and every domain, there is a codomain minus pi by 2 to pi by 2, and range is minus pi by 2 to pi by 2, so that you can write inverse function minus 1 comma 1. Principal value a branch is minus pi by 2 to pi by 2. Let one example of this inverse. Let sin inverse x. It will sin inverse 1 by 2. You can see that principal value of this sin inverse function is minus pi by 2 to pi by 2. Then sin inverse 1 by 2 is sin inverse pi by sin pi by 6. Sin 30 is this. Then answer is pi by 6. Then pi by 6 is the element of minus pi by 2 to pi by 2. Your answer is minus pi by 2 to pi by 2. Another, let sin inverse minus 1 by 2. Then the result of this question is sin inverse minus 1 by 2. Inverse function lie between minus pi by 2 to pi by 2. And the principal value of this function is always minus pi by 2 to pi by 2. So that if negative sign, so take negative, if positive sign, take positive, minus pi by 2 to pi by 2. That is sin inverse sin minus pi by 6. Result is minus pi by 6. It means minus pi by 6 is the element of minus pi by 2 comma pi by 2. So that minus pi by 6 and the element is minus pi by 2 comma pi by 2. Similarly, next one is cos inverse x, tan inverse x, cot inverse x, sec inverse x. You can write the simplest form of this question. Suppose cos inverse minus root 3 by 2. Cos range is 0 to pi. Cos is negative in the second quadrant and is 0 to pi. So that root 3 by 2 is the value of cos, which cos root 3 by 2 cos is 30. cos pi by 6. But this is negative. You can write pi minus pi by 6. Then 5 pi by 6 is the answer. Because cos inverse lie between 0 to pi. So that no negative value in this principal branch. If no negative value in the principal branch, you can use 0 to pi. If 0 to pi, then the first positive value, first quadrant is positive, all positive, and second quadrant cos is negative. Then you can write pi minus angle, pi minus alpha or pi minus pi by 6. So that this answer is 5 pi by 6. Elementary properties of ITF, inverse trigonometric function. Property number 1. Elementary properties of inverse trigonometric function are valid within the principal values. This is valid for the principal branch. First, sine inverse sin x is equal to x. X is the element of minus pi by 2 to pi by 2. This is the principal branch. Second one, cos inverse x is cos inverse cos x is equal to x. X is the element of 0 comma pi. 0 comma pi is the principal branch. Third one, tan inverse tan x is equal to x. X is the element of minus pi by 2 comma pi by 2. And fourth one is cot inverse cot x. Cot x plus cot x is equal to x. X is the element of 0 comma pi. This is also the principal branch. And fifth property again is cosec inverse cosec x is equal to x. X is the element of minus pi by 2 to pi by 2 excluding 0, because cosec 0 is not defined, so that the result of this is x is the element of minus pi by 2 to pi by 2 except 0. Then sec inverse sec x is equal to x. X is the element of 0 comma pi except pi by 2. So this is the elementary properties of inverse trigonometric function. If sine inverse sin x, then it is equal to x, where this is the principal branch, minus pi by 2 to pi by 2. Always sine inverse sin x lie between principal branch, cos inverse x, cos x lie in principal branch. Similarly, tan inverse, cot inverse, cosec inverse, and sec inverse also lie in the principal branch. Next, property number 7. Sine inverse x is equal to x, where x is the element of minus 1 comma 1. Then eighth one, cos inverse x is equal to x. X is the element of minus 1 comma 1. Next one is tan inverse x is equal to x. X is the element of real. Next, cot inverse x is equal to x, where x is the element of also real. Next, cosec inverse x is equal to x. Here, this principal branch is x is the element of minus pi by 2 comma pi by 2. It means this is x is mod of x is greater than equal to 1. Sec inverse x is equal to x, mod of x is greater than equal to 1. So this is the first property. Sin inverse sin x, cos inverse cos x, tan inverse tan x, cot inverse cot x according to the principal branch. Then find the value of sin inverse sin x by using the principal branch in this way. Property number 2, reciprocal property. Reciprocal property means cosec inverse x is equal to sine inverse 1 upon x, where mod of x is always greater than equal to 1. Similarly, sec inverse x. This is cos inverse 1 upon x. Here mod of x is always greater than equal to 1. Next one is cot inverse x. Cot inverse x, tan inverse 1 upon x if x is greater than 0. And pi plus tan inverse 1 upon x if x is less than 0. So reciprocal property, cosec inverse is written as sin inverse 1 upon x, sec inverse is written as cos inverse 1 upon x, and cot inverse x written as tan inverse 1 upon x. Here x is greater than 0, and when x is less than 0, then you can write pi plus tan inverse 1 upon x. Suppose one question ले लिया इसमें examples, cosec sin inverse 1 by 5 plus sec cos inverse 1 by 3. Sin inverse 1 by 5 is written as cosec inverse 5. Similarly, sec cos inverse 1 by 3 is written as sec inverse 3. Here 5 plus 3, result is 8. So this is the reciprocal property, sin inverse x converted to cosec inverse x, then sin inverse x equal to cosec inverse 1 upon x, cos inverse x is equal to sec inverse 1 upon x, tan inverse x is equal to cot inverse 1 upon x, vice versa. Next, some properties. Property number 3. Sin inverse minus x is equal to minus sin inverse x. This is x is element of minus 1 comma 1. Similarly, cos inverse minus x is written as pi minus cos inverse x, and x is the element again minus 1 comma 1. Tan inverse minus x, this is equal to minus tan inverse x. X is the element of real. Cot inverse minus x is equal to pi minus cot inverse x. X is again element of real. Similarly, cosec inverse minus x is equal to minus cosec inverse x, and mod of x is greater than equal to 1. Sec inverse minus x is equal to pi minus sec inverse x, and mod of x is greater than equal to 1. This is the property number 3. Next property is complementary. Complementary means sin, cos, tan, cot, sec, cosec. These are the complementary. So next property is complementary property. Complementary property. In complementary property, property number 1, sin inverse x plus cos inverse x is equal to pi by 2. How can you prove that sin inverse x plus cos inverse x is equal to pi by 2? Let sin inverse x is equal to y, then x is equal to sin y. You can write sin y as cos pi by 2 minus y. Then this, by shifting this, cos inverse x is equal to pi by 2 minus y, and y is cos inverse x is equal to pi by 2 minus sin inverse x. So that cos inverse x plus sin inverse x is equal to pi by 2. Similarly, tan inverse x plus cot inverse x is equal to pi by 2. Sec inverse x plus cosec inverse x is equal to pi by 2. Tan inverse x plus cot inverse x is equal to pi by 2. Third one is sec inverse x plus cosec inverse x is equal to pi by 2. This is the complementary property. Sin 90 minus theta cos theta, cos 90 minus theta sin theta, tan 90 minus theta cot theta, cot 90 minus theta is equal to tan theta. So that sin inverse x plus cos inverse x is equal to pi by 2. Similarly, you can prove that tan inverse x plus cot inverse is equal to pi by 2. Similarly, sec inverse x plus cosec inverse is equal to pi by 2. Next one is conversion property. Conversion sin, cos, tan, cot, sec, cosec conversion. Conversion property. How to convert sin to tan or cot, sec, cosec. Suppose this question is given sin inverse x. You have to convert this sin inverse x, cos inverse and tan inverse. Then sin inverse x is equal to cos inverse root of 1 minus x square is equal to tan inverse x upon root of 1 minus x square, where 0 is less than equal to x, less than equal to 1. You will range 0 to 1 में lie करनी चाहिए. You can solve this by using simple way, triangle method. Sin inverse x, let sin inverse x is equal to y, then x is equal to sin y. Sin is perpendicular upon hypotenuse. So here angle this is y, perpendicular x, hypotenuse is 1 and base is 1 minus x square. So x is equal to sin y, this convert to the in triangle form. X is equal to sin y, sin is perpendicular upon hypotenuse, so that base is root of 1 minus x square. You can write cos inverse. Cos is based upon hypotenuse, means cos inverse under root 1 minus x square. Tan inverse, tan is perpendicular upon base, x upon root 1 minus x square. So you can change sin inverse to cos inverse to tan inverse. Then sin inverse x is equal to cos inverse root 1 minus square is equal to tan inverse x upon root 1 minus x square. Similarly, cos inverse x. Cos inverse x is equal to sin inverse under root 1 minus x square is equal to tan inverse root of 1 minus x square upon x, where 0 is less than equal to x, less than equal to 1. Here, triangle, cos is based upon hypotenuse. Then perpendicular is 1 minus x square. You can see that sin is perpendicular upon hypotenuse, root 1 minus square. Similarly, tan is perpendicular upon base, then tan inverse root 1 minus x square upon x. So this is change cos to sin to tan, sin to change in cos or tan. Next, property number 6. This is the property number 5. Next one is property number 6. You can prove the properties. First, property number 6. Tan inverse x plus tan inverse y. Tan inverse y is equal to, in some cases, tan inverse x plus y upon 1 minus xy if xy is less than 1. Next, pi plus tan inverse x plus y upon 1 minus xy if xy is greater than 1, x comma y is greater than 0. And last one is minus pi plus tan inverse x plus y upon 1 minus xy if xy is greater than 1, x comma y is less than 0. Tan inverse x plus tan inverse y, first check xy product is less than 1. You can use this formula, tan inverse x plus y upon 1 minus xy. If xy is greater than 1 and x comma y is greater than 0, so that you can use formula pi plus tan inverse x plus y upon 1 minus xy. Otherwise, next part is xy is greater than 1 but x comma y is less than 0. Then use this formula minus pi plus tan inverse x plus y upon 1 minus xy. Similarly, tan inverse x minus tan inverse y. Tan inverse x minus tan inverse y means tan inverse x minus y upon 1 plus xy if xy is greater than minus 1. Second point, pi plus tan inverse x minus y upon 1 plus xy if product x greater than 0, y less than 0 and product xy is less than minus 1. Then use pi plus tan inverse x minus y upon 1 plus xy. Third one is minus pi plus tan inverse x minus y upon 1 plus xy if x is less than 0, y is greater than 0 and xy is equal to minus 1. Then use the formula minus pi plus tan inverse x minus y upon 1 plus xy. Then tan inverse x minus tan inverse y, if xy is greater than minus 1, use the formula tan inverse x minus y upon 1 plus xy. If x is greater than 0 but y is less than 0 and product of these number is xy less than minus 1, then you can use the formula pi plus tan inverse x minus y upon 1 plus xy. And if x is less than 0, y is greater than 0, but xy is equal to minus 1, then use the formula minus pi plus tan inverse x minus y upon 1 plus xy. So this form is by using tan a plus b. You can prove this by let x is equal to tan alpha, y is equal to tan beta, and putting the value x and y in this equation, tan inverse tan alpha plus tan beta upon 1 minus tan alpha tan beta. This is the formula of tan alpha plus beta. Tan inverse tan alpha plus beta, and you can write alpha plus beta. It means tan inverse x plus tan inverse y. This is the formula of tan inverse x plus tan inverse y is equal to tan inverse x plus y upon 1 minus xy, proved by this way. Next, property number 7. Property number 7 base है 2 sin inverse x, 2 cos inverse x, 2 tan inverse x. So first of all, 2 tan inverse x. 2 tan inverse x equal to sin inverse 2x upon 1 plus x square, where mod of x is less than equal to 1 or minus 1 is less than equal to x less than equal to 1, and it lies between minus 1 to 1. You can prove this formula. Let x is equal to tan alpha. Then this is written as sin inverse 2 tan alpha upon 1 plus tan square alpha. This is sin inverse sin 2 alpha. It means 2 alpha. Therefore, alpha is equal to tan inverse x. This means 2 tan inverse x. You can prove this formula by using sin 2 theta or sin 2 alpha form. Sin inverse 2 tan alpha upon 1 plus tan square alpha. 2 tan alpha upon 1 plus tan square alpha is written as sin 2 alpha. Sin inverse sin 2 alpha is 2 alpha. Then alpha is tan inverse x, so that 2 tan inverse x is written as sin inverse 2x upon 1 plus x square. Next one is 2 tan inverse is cos inverse 1 minus x square upon 1 plus x square. Cos inverse 1 minus x square upon 1 plus x square. 0 is less than equal to x, less than equal to 1. 0 to 1 lie करेगी value cos में. 2 tan inverse x is equal to cos inverse. Here let x is equal to tan theta or tan alpha. Then cos inverse 1 minus tan square alpha upon 1 plus tan square alpha. This is cos 2 alpha. Cos inverse cos 2 alpha. It means 2 alpha. It means 2 cos inverse 2 tan inverse x. So you can write the formula 2 tan inverse to cos inverse 1 minus x square upon 1 plus x square. This is the one very important formula. You learn it. 2 tan inverse x is equal to sin inverse 2x upon 1 plus x square is equal to cos inverse 1 minus x square upon 1 plus x square is equal to tan inverse 2x upon 1 minus x square. 2 tan inverse convert with sin inverse, cos inverse and tan inverse. Next, property number 8. 2 sine inverse x is equal to. Property number 8. 2 sine inverse x. This is equal to sine inverse 2x root of 1 minus x square. Where if x is element of minus 1 by 2 comma 1 by 2. Prove that 2 sine inverse equal to sine inverse 2x root 1 minus x square. Let x is equal to sine alpha, then sine inverse 2 sine alpha root of 1 minus sine square alpha, then sine inverse sine 2 alpha. It means 2 alpha, means 2 sine inverse x. You can prove this 2 sine inverse x equal to sine inverse 2x root 1 minus x square, putting x in place, putting x sine alpha in place of x. Then you can write sine inverse 2 sine alpha root 1 minus sine square alpha, or 1 minus sine square alpha is cos square alpha after taking root, then cos alpha, 2 sine alpha, cos alpha, that is sine 2 alpha. It means 2 sine inverse x. Next, 2, 3 formulas are similarly. 2 cos inverse x is equal to cos inverse 2x square minus 1, where x is the element of 0, 1. If next one is 3 sine inverse x. Sine inverse 3x minus 4x cube. If x is the element of minus 1 by 2 comma 1 by 2. Next one is 3 cos inverse x. Cos inverse 4x cube minus 3x. If x is the element of 1 by 2 comma 1. And last one is 3 tan inverse x. 3 tan inverse x equal to tan inverse 3x minus x cube upon 1 minus 3x square. If x is the element of minus 1 by 3 comma 1 by 3. 2 cos inverse x, putting the value of cos alpha in place of x, then 2 cos square alpha minus 1, that is cos 2 alpha. Similarly 2 cos inverse x. In this case, putting the value of in place of x is sine alpha. 3 sine x minus 4 sine cube x is equal to sine 3x. So that this is 3 sine inverse x. Similarly, in place of cos inverse 4x cube minus 3x, putting the value of cos alpha in place of x. And in this question, putting the value of tan alpha in place of x. Then you can write this question tan inverse 3 tan alpha minus tan cube alpha upon 1 minus 3 tan square alpha. That is tan 3 alpha, means 3 tan inverse x. Property number 9. Property number 9 is basically based of compound angles. Means sine inverse x plus sine inverse y is equal to sine inverse x root of 1 minus y square plus y root of 1 minus x square. If plus then plus, if minus then minus. Here, if mod of x comma mod of y is less than equal to 1 and x square plus y square is less than equal to 1. So you can use this formula. How to prove this formula? Let RHS sine inverse x root 1 minus y square plus y root 1 minus x square. Let x is equal to sine alpha, y is equal to sine beta. Then sine inverse sine alpha root of 1 minus y square with 1 minus sine square beta plus sine beta root of 1 minus sine square alpha. Then sine inverse sine alpha cos beta plus sine beta cos alpha. This is the formula of sine alpha plus beta. It means sine inverse sine alpha plus beta. It means alpha plus beta. Alpha is sine inverse x. Beta is sine inverse y. This is sine inverse x plus sine inverse y. If formula is sine inverse x minus sine inverse, then write sine inverse x root 1 minus y square minus y root 1 minus x square. In place of plus, this is minus, this is minus, this is minus, then this is sine inverse x minus sine inverse y. Similarly, you can prove this sine inverse x minus sine inverse y. Again, cos inverse x plus cos inverse y. Cos inverse x plus cos inverse y and cos inverse x minus cos inverse y. First of all, cos inverse x plus cos inverse y. This is equal to cos inverse xy minus root of 1 minus x square root of 1 minus y square. Here same condition, if mod of x mod of y is less than equal to 1 and x plus y is greater than equal to 0, this formula will be used. How to prove? Let x is equal to cos alpha, y is equal to cos beta. Putting the value of x and y in RHS side, then cos inverse, cos alpha, cos beta, minus sin alpha, sin beta. Because 1 minus cos square is sin square, root of this is sin. 1 minus cos square beta is sin square beta, then sin beta. This is the formula of cos alpha plus beta. Alpha plus beta. It means cos inverse x plus cos inverse y. You can prove this cos inverse x plus cos inverse y, that is cos inverse xy minus root of 1 minus x square root of 1 minus y square. If mod of x mod of y less than equal to 1 and x plus y is greater than equal to 0, then this formula will be used. After that, cos inverse x minus cos inverse y. Cos inverse x minus cos inverse y, there is a minus sign, then this is plus. And last part of the inverse trigonometric function is how to convert inverse function in the simplest form. The first is serial number, then expression, how substitution, what substitution should be put so that convert this in the simplest form. Root 1 plus x square, then put x is equal to tan theta or cot theta. Means 1 plus tan square theta, that is sec square theta, means sec theta. 1 plus cot square theta is cosec square theta, it means cosec theta. So you can put, if the expression in inverse form, that is root 1 plus x square, you can put x is equal to tan theta or cot theta. Similarly, the expression is root of a square plus x square, put x is equal to a tan theta or a cot theta. If the expression is root of 1 minus x square or 1 minus x square, put x is equal to sin theta or cos theta. If the expression is root of a square minus x square, put x is equal to a sin theta or a cos theta. If the expression is in the form of x square minus 1, put x is equal to sec theta or cosec theta. If the expression is in the form of x square minus x a square, put x is equal to a sec theta or a cosec theta. If the expression is 1 plus x square plus minus root 1 minus x square, put x square is equal to cos 2 theta. Because 1 plus cos 2 theta is equal to 2 cos square theta. 1 minus cos 2 theta is equal to 2 sin square theta. So that this expression is converted into the simplest form. Similarly, 1 plus x square upon 1 minus x square, 1 minus x square upon 1 plus x square. In this way, you can always put x square is equal to cos 2 theta. Similarly, a square plus x square plus by root a square minus x square, a square plus x square, a square minus x square, a square minus x square upon a square plus x square. Again, put x square is equal to a cos 2 theta. A square cos 2 theta. In place of x square, you can write a square cos 2 theta. A square plus a square cos theta. Taking common a square, then 1 plus cos 2 theta, or 1 plus cos 2 theta is written as 2 cos square theta. Same, root 1 plus x plus minus root 1 minus x. Put x is equal to cos 2 theta. Put x is equal to cos 2 theta. Similarly, in this case, put x is equal to a cos 2 theta. So this is the basic form by substitution to convert the inverse trigonometric function in the simplest form. In this way, you can change the question in the simplest form, and further you can apply this form, differentiation and integration also. Thank you.